Hi guys, welcome to this revision summary video for everything that you need to know for energy in reactions, so exothermic and endothermic. So one of them is where the temperature increases, one is where the temperature decreases. If the temperature goes up, you have an exothermic reaction, and if you have an endothermic reaction, the temperature goes down. You also need to know the definition in terms of energy. So for exothermic, heat energy is given out to the surroundings, and for endothermic, heat energy is taken in from the surroundings. You need to know some examples of exothermic and endothermic. Exothermic, neutralization, displacement. Endothermic, salt dissolving. They're the key ones, make sure you know them as examples for the exam. Now you can show exothermic and endothermic reactions by using reaction profiles. Reaction profiles shows you the energy of the reactants and products, and show you what happens as the reaction goes on. Now the key thing here is for exothermic, the products have less energy than the reactants, and the endothermic ones have more energy than the reactants. For exothermic reactions, that energy change is the energy given out to the surroundings, which is why the surroundings heat up. And for endothermic, that energy is taken in from the surroundings, which is why the temperature goes down. The next section is going to have a look at what happens in terms of bond breaking and bond forming, and how that links back to exothermic and endothermic. So the first thing that we have to do in any chemical reaction is we have to break the bonds. To break the bonds, you must put energy in. If you put energy in, it means bond breaking is endothermic. The second part of any reaction is bond forming. So new bonds form and energy is given out. If energy is given out, that makes bond forming exothermic. So how do we know if a reaction is exothermic or endothermic overall? Again, we look at our reaction profiles. The energy taken in is the energy needed to break the bonds. That's the part that goes up. The energy given out is the energy for forming new bonds. If more heat energy is given out when new bonds form than taken in when bonds are broken, that makes it exothermic overall. It's a very similar explanation for endothermic. The energy is still taken in when bonds are broken, and energy is still given out when new bonds form. However, for it to be endothermic overall, more heat energy is taken in when those bonds are broken than given out when new bonds form. This next section only appears on the higher paper, and that is having a look at bond breaking and bond forming, and how you can calculate whether something is exothermic or endothermic overall. So you will be given a table in the exam that looks like this. It will have the bonds in and it will have the bond energy, so that is the energy needed to break or form the bonds. So if we start off with hydrogen, I have two HH bonds. You can see that up above. And I have one O2 molecule, which means I have one O double bond O. So what I need to do is have a look in my table. If we start off with the HH, I have 2 times 436 kilojoules per mole. I have one O double bond O, which means I have 1 times 498 kilojoules per mole. So my total energy needed to break all the bonds is 872 plus 498, which comes to 1,370 kilojoules per mole. I now need to do the same on the right hand side for my new bonds forming. I have H2O and I have 2 of them, which means I have 4 HO bonds, which means 4 times my 464. So my energy to form new bonds is 1,856 kilojoules per mole. The next step, I have to work out the change in energy, and that is nice and simply the energy for breaking bonds, take away the energy for forming new bonds. So for example here, 1370 minus 1856 comes to minus 486 kilojoules per mole. So how does this link back to whether something is exothermic or endothermic? Nice and simply, if the answer is negative, it's exothermic. If it's positive, it's endothermic. So here it's a negative minus 486. Therefore, this reaction is exothermic, so the temperature is going to go up, heat energy is going to be given out. This final section is going to have a look at catalysts and enzymes. So if we start off with catalysts, nice and simply you need to know the definition, which is they speed up a chemical reaction, but they don't get used up, so the mass stays the same. They remain unchanged at the end. The explanation for that is all to do with activation energy. Activation energy is the energy required to start a reaction by breaking the bonds. And this is where it occurs. So the way catalysts work is they lower the activation energy, meaning that although you have the same number of collisions because you haven't changed the temperature, the concentration or the surface area, more of those collisions are successful because they don't need as much energy for a reaction to occur. Therefore, the rate of reaction will increase. Now, enzymes are very similar. They are biological catalysts. They speed up the reaction and they remain unchanged at the end. They stay the same. For example, fermentation. They're used to convert glucose into ethanol and they make the reaction happen quicker. And then finally, the only other thing you need to know from this video is what a catalytic converter is. They're used in cars, nice and simply, and they turn harmful gases into safer ones. So for example, nitrous oxides into nitrogen, carbon monoxide into carbon dioxide. And they do that by using a palladium or platinum catalyst. As we said, those catalysts lower the activation energy, so more of those reactions are going to be successful in turning them back into safer gases. They also work better at high temperatures because you've got higher kinetic energy, more successful collisions per second, and they have a large surface area for a larger surface area to volume ratio for more frequent collisions. And that brings this video to an end. Hopefully you found it useful. Good luck in preparing for your exams. Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can also subscribe to my channel, you can check out the latest video, and you can visit my website up above here. Bye now.